All right, so you've all seen the videos, right? Boston Dynamics' Atlas robot doing backflips, parkour. I mean, it's cool stuff, no doubt. But what we're diving into today is, well, it's way bigger than that. We're talking about the brand new AI that's teaching Atlas not just how to dance, but how to actually work. This is the real game changer. Let's get into it. And that really is the billion-dollar question, isn't it? I mean, how do you go from a robot that can do a cool pre-programmed routine to one that's genuinely useful, one that can adapt and actually help out in the real world? It's been one of the toughest nuts to crack in robotics. So how are they finally doing it?
You know, for decades, this has been the holy grail. Building a humanoid robot that's actually versatile has felt, well, almost impossible. Because it's not just about getting a robot to walk on two legs. The real challenge is getting it to interact with a world that was designed, from the ground up, for us humans.
And yeah, this list really just scratches the surface of how complex this is. Think about it. A truly useful robot has to be able to handle anything. A super heavy car tire 1 minute, a delicate piece of cloth the next. It's got to coordinate its entire body, all 50 of its joints, just to move, stay on its feet, and, not smash its own arm into its face. And the real kicker? It has to be smart enough to react when, inevitably, things go wrong.
Okay, so here's the big realization they had. The old way of doing things, programming a robot for one single task, it just doesn't work. It's a dead end. The real breakthrough, the big strategic pivot, is to stop thinking about specialists and start creating an AI generalist, an AI that can learn a whole bunch of different skills, just like we do.
So if a specialist is out, what's in? Well, the answer comes from this incredible collaboration between Boston Dynamics and the Toyota Research Institute. They've developed this breakthrough tech, and it's called a large behavior model. You're going to be hearing a lot more about LBMs.
So what on earth is a large behavior model? Well, think of it like this. It's an AI that learns by watching. That's the key. Instead of an engineer painstakingly writing code for every single tiny movement, the AI is trained on this massive video library of demonstrated behaviors. This lets it pick up the general skill, not just a rigid set of instructions.
And this chart here, it nails the difference. The old way, traditional programming, is like giving the robot a super strict IKEA instruction manual. If one screw is missing or a step is out of order, the whole thing falls apart. It's brittle. But large behavior models, that's totally different. It's like having the robot shadow an expert for thousands of hours. It's not just learning one procedure, it's learning the craft, the actual skill.
Yeah, this really is the best way to put it. You're not a coder anymore, you're a coach. You're showing the AI how it's done, guiding it, not just giving it orders.
Okay, so this whole coaching thing sounds great, right? But how does it actually work? I mean, how do you get all that knowledge from a person into the robot's brain? Well, the answer is surprisingly human. And honestly, it's pretty cool.
That's right. A human teacher literally pilots the robot. They step into a custom VR system and perform the task, and the robot learns by watching and mimicking every single move. It's like a high-tech puppet show, but the puppet is learning to think for itself.
And the setup itself is straight out of science fiction. The human operator puts on a VR headset, and boom, they're seeing the world through the robot's eyes, in full 3D. They've got controllers and trackers, so they're controlling the robot's entire body. The operator crouches, Atlas crouches. The operator reaches, Atlas reaches. It's this perfect one-to-one connection, which means the training data you get is just pristine.
And this whole thing creates this amazing feedback loop, what they call a training flywheel. So, step 1, a human demonstrates the task in VR. Step 2, they process that data. 3, they feed it all into the AI model to train it. And then the most important part, step 4, they test the AI on the real robot. And wherever it struggles or fails, bam, that tells them exactly what new stuff they need to show it. So with every single spin, this flywheel makes the AI smarter and more capable.
And the brain we're talking about here is just massive. The AI model has 450 million parameters. You can think of those as tiny little dials or knobs that the AI adjusts as it learns. It's that incredible scale that lets it soak up all this complex data and then, actually generalize from it.
Okay, so that's the theory behind it. But what does this look like when the rubber meets the road? Let's check out a pretty complicated task that this one single AI can now pull off all on its own.
So in this scenario, they've got this spot workshop task. Atlas is just given some simple text commands. First, it has to grab these spot robot legs, fold them up just right, and place them on a shelf. Then, it has to grab some faceplates and put those in a bin. And finally, it clears everything else off the cart into a bigger bin. The key thing to remember is, This whole complex chain of actions is being run by that one single generalist AI.
But listen, here's the real magic. I mean, getting the task right is cool, but the real breakthrough is what happens when things go wrong. What happens when Atlas, say, drops a part by accident?
See? That ability to recover from a mistake, it isn't programmed in. No one wrote an if-then statement for if you drop the part, do this. It's learned. During training, the human teachers just showed it what to do. They'd drop a part on purpose and show the robot how to pick it up. The AI saw those examples and just figured out how to adapt all by itself. It's incredible. And this quote from the research team just says it all perfectly. If you can demonstrate it, the robot can learn it. That's the takeaway. The specific task almost doesn't matter anymore. If a person can show the robot how to do something, anything, the robot can learn to do it too.
Oh, and get this. This is the kicker. The student actually becomes the master. Because the AI isn't just copying the human's moves, it's learning the goal of the task, so it can then figure out the most efficient way to do it. And in testing, Atlas can perform these tasks up to 3 times faster than the human who taught it in the first place. How wild is that?
So let's zoom out. What does this all mean? Why is this such a big deal for the future of robotics? Because this isn't just another cool tech demo. This represents a fundamental, ground-up shift in how we teach robots to do, well, anything.
The really crucial part is that this approach smashes the old barriers. You don't need a whole team of PhDs spending a year writing custom code for every single new behavior anymore. Now, you just need someone to demonstrate it. This data-first approach means you can scale up what a robot can do at a speed we've never seen before.
So this is why it all matters. We're talking about creating truly robust robots that can generalize skills from one task to another. It makes super complex things like handling soft cloth or heavy tires suddenly achievable. It completely changes the game for developing robot behaviors, making it way simpler and faster. We are finally moving closer to the dream of a truly useful, general-purpose humanoid robot.
Now look, this is all still pretty new, but the foundation is now there for a massive acceleration in what robots can do. Which really leaves us with one huge, exciting question to think about. Now that we can basically teach a robot to do anything we can show it, what are we going to teach them to do next?